Here we go again. Tuesday, September 19th. Problem 12. All congruent subgroups of level 2. So we have gamma and gamma 2. And we must find all the groups in between and describe them and find a fundamental domain. So we need the representatives for the cosets of the groups, and we must know the indices for that as well. This is a technical question. So it's generated by the cosets, or larger than each coset of gamma 2. So it's just to go through and see what they generate. Now t squared lies in gamma 2. So we have one generated by t. And s squared gives unity as well, so we have one generated by s. And they seem to have so that gamma 2 has index 2, and that means that we should have 3 cosets. Let's take a 4. And a 4 to the third. So this lies in gamma 2. So that means A4 is of order 3. I write alpha 4 like they do in the book. I believe there is only one set of alpha, so I believe that, that's gamma 6 and gamma, This is another family. So let's check whether A5 and A4 are in the same. Oh, there's also A4 and S. Now, they must generate gamma, of course, because explicitly A4S equals T, so they generate all of gamma. Now, what is that? That's a surprise. Well, let's look at A5 first. So A5 is a group of, generates a group with 3 elements. Oh, this is almost A5, isn't it? That lies in gamma 2. So that means A5 lies in the group generated by A4. And finally A6 it has order 2. That reminds me of T. So if we say A2 dot A6 squared, it didn't like that. How about A6 itself? No? Well, well, well. So they are coupled. So that's one group of 3 elements. And how about A6? Oh, it's a group that looks like gamma naught. You see, we have gamma naught of 2, which is this. We're naught here. And then I believe we have another one. With an order up here, of course, modulo 2. If we multiply that with itself, I'll just do it. Now naught was arbitrary. But that must be unity, of course, in this case. No, that was the one we had, so we need to have naught here and then a down here. And then let's square it. So it's another group we have. Which was generated by, I believe it was alpha 6. Yeah. So T, the one, so I have 4 subgroups. That's a surprise, really. Next, we need to find representatives for the side classes. Of course, we have the identity for all of them, and then I believe we have S for this guy. Oops, there should be 3, so that's not very sensitive. These only have 2, so that should be more easy. There's the identity and then another guy. This is not very systematic. I'll just check how to be more systematic about it. We've just played a little around with stuff. So it's time for a break, and then I'll try to be more systematic. Well, I had my break, but I didn't really get any wiser. I haven't verified that these 3 groups are distinct. It seems so, though. I would like to choose T as a side class whenever possible. And here it's not. Here it should be possible because ST does not lie in gamma 2. And here it should be possible. Now how about gamma 6? That has naught up there, so it should be possible as well. All right. This one is finished. We have 2 side groups, 2 side classes, and it has index 2 in gamma. But we need to find another one in the other 3 cases. looking at the picture, when we have I and S and cannot use T, then our only choice is gamma 4, alpha 4. So let's check whether alpha 4 is possible. So we want alpha 4 here. So it's a question whether S alpha 4 lies in gamma naught. And it does. This is equivalent to T modulo 2. Strange. Well, let's check the group generated by S. We have 1 and T. We can't use S itself, so the only other guy that comes into play is alpha 5. So let's check whether alpha 5 works. So it's T alpha 5. That gives S. But that's what it should give, because those two multiplied should lie in the group because they give unity. That means that my condition is actually silly. So I claim that we should be able to use alpha 4 here. And 1, 3, alpha 6. Shouldn't we be able to use S here? No. Oh yeah, that's possible. So I believe TS lies in the group generated by alpha 6. Let's check that. TS, yeah. Well, I'm confused, and it's pretty poor because it's some very fundamental technique. I'll just think it through once again. I worked a little on this. I believe I found a description of the groups as well as examples of cosets. This one, of course, is gamma naught of 2. This one, either the diagonal elements are even or all the off-diagonal elements are even. That was S and unity. And then alpha 4 generates alpha 4 and alpha 5. So when we look at them, we can see that there is 1, 0, and only 1 in the diagonal elements, or both of the off-diagonal elements are even, as we have it in gamma 2. And then this, of course, is gamma upper naught. Now alpha 4s, so s to minus first, that s alpha 4. We have that here. Those, they lie in gamma upper naught. So it's not the one generated by t. And then alpha 5 and t to minus first alpha 5. That's not in the group generated by S. And finally, S and T, so it's T to minus first S, or just ST. And ST we already have. That's this guy, and it lies in, no, where does that lie? It has one diagonal naught. So it lies up here, so it doesn't lie in the group generated by A6. So now we have our coset, we have a description of the group, the indices, which I haven't written, and then the number of side classes where the indices are easy to count, like 2 and 3. Time to look at my map of the fundamental domains. Now what is this? The level 2 subgroup of index 2. That must be the one generated by A4. One or both I and T. Let's see what I took here. I took I and S. So my description, I agree with my description. It's A4. But they use S as, well, that's okay, that's another possibility. Oh, when I use T, I only have one cusp. And here they have to argue that, or I had to argue that it only had one cusp. Well, the next, the Hecke group, 2 even off diagonal or 2 even diagonal numbers, the rest being odd. There are 3 level 2 groups of index 3. That's what I found today as well. the Hecke group, two even off-diagonal numbers or two even diagonal numbers. That's what I wrote here. That's the one generated by S. 1t and alpha 5. That's exactly what I have here. Very nice. And gamma naught. So we have F, SF, and this guy, what was that? That was alpha 5. No, alpha 4 to minus 6. Let's see if I have alpha 4 as well. That's exactly what I have. And the final one, gamma upper naught. Yeah, gamma upper naught. And that's S and T, right. Well, that solves the problem